Hey guys, welcome to Coronavirus Earth Science. We're on weather day 6, and today we're talking about breezes, which, is a type of wind. Just so that we all are aware, for this upcoming week, these are the two things that you are being graded on that I will be checking on Saturday like usual. The Castle Learning is going to count as a homework grade. Remember, your grade is your grade now that we are in the 4th marking period, and the Google form is counting as a quiz as it has been thus far. All right, this is just reiterating what we just said. Our aim, how do we differentiate between land breezes and sea breezes? And you guys should be able to tell me this already. Winds get their names based on where they come from. So a sea breeze is a breeze that is coming from the sea. A land breeze is a breeze that's coming from land, okay? So before we get into our do now questions and the lesson, I just have to review pressure with you. I told you that this is the most important part of weather, and if you know this, you know everything. All right, low. That W is really important because that lets you know that low pressure systems are warm temperatures and wet in terms of humidity. That makes high pressure systems cool and dry. All right? A cool, dry day, clear skies, no rain, that is nice weather. Your warm, humid, sticky, raining, that's your bad, stormy, unstable weather. Okay, then we went into how does wind work? Wind in these surface pattern systems of a low pressure, I told you to remember this and this, Hock and Lick. Okay, low pressure goes in counterclockwise, high pressure goes out clockwise. You could also remember these. Remember I said loco, low pressure is convergent, which is all the arrows coming in, and this is divergent, okay? So if you were to draw this, you would draw it in and counterclockwise, like this, okay? Kind of like a tornado, right? And then if you had high pressure, it's going the opposite, out and clockwise, okay? The last thing that you have to know for today, which is really important, is that winds always blow from high pressure systems to low pressure systems, okay? And if you remember that, you should be good for today. All right, so let's move forward. Which map best represents the surface wind pattern around northern hemisphere high pressure system? Hock, out and clockwise. The only one here that's going out and clockwise is choice 3. Okay? Next, as wind velocity decreases, so that means it slows down, the distance between isobars on a weather map will do what? All right, the distance between them is going to increase. Remember, we said that wind speed is the same thing as the pressure gradient. Okay, so when you're looking at isobars, if you have this versus this, this is going to be strong winds, and this is going to be weak winds. Okay, moving on. So, I live in Wantagh, as you guys know. In Wantagh, going along the Wantagh Parkway, there is a bike path, and it goes all the way from basically Cedar Creek Park, and it leads to Jones Beach. And then there's another path that will continue going this way out to Tobay, and now I hear that they're going to extend that all the way out to Captree State Park, which is pretty cool. So from here, which is Wantagh, Cedar Creek, to here is about 5 miles. okay? And one thing that I have noticed plenty of times, which is terrible, is that the wind. The wind is terrible. Sometimes you can get a great smooth ride with the wind blowing at your back, and then other times you can be riding into the wind, and that normal half-hour ride just became an hour because you're struggling and fighting the wind the entire time. So actually, you have to time the bike rides properly. What time of day will you be riding to the beach, and what time of day will you go back home? So that's the question I wanted to pose to you. This is a lot better in class, but either way, we'll get the same picture. Why does the direction of the wind change? So there have been plenty of times where I rode to the beach and I had to fight the wind the entire time, hung out at the beach, and then when I had to ride home, the wind switched, and now again, I'm riding into the wind. It's not like one way it's at my back and one way it's in my face. All right, so the wind changes directions. So why is that? So to help us think the right way, I'm just going to remind you of a couple things. Time lag. All right, we went over this back in astronomy. The hottest temperatures of the day should be noon, but it's actually going to be 2 p.m., right? You got that little 1-2 hour delay. And then the coolest temperatures are going to be at sunrise, okay? That's going to be the coldest temperatures of the day. So that's number one helpful hint. Number two, specific heat. All right, remember what specific heat is. It's how long it takes for them to change their temperatures. All right, and if you remember, water takes a long time to change its temperatures. All right, whereas land is going to take a short time. They change their temperatures very fast, the land. Because on land, on the continental crust, it's going to be made of granite, right? We remember this from our dynamic Earth. And the ocean is going to be water. All right, so you have your specific heat chart, which is page 1 in your reference table. Then our relationships between temperature and pressure. So we know low pressure is going to be your warmer temperatures, and your high pressures are going to be your cooler temperatures. Next, what determines the direction of the wind? They go high to low. All right, so let's get into it. Right here on this diagram, it is daytime, right? Daytime. So here at daytime, you have the sun beaming down. It's 2 p.m. It's the hottest time of the day. What's going to be hotter, the land or the ocean? Remember what we said. Land has the lower specific heat, right? Land has a lower specific heat. That means that it changes its temperatures very easily. So let's just say the temperatures of the waters are 65 degrees Fahrenheit and the temperature of the land is 80 degrees Fahrenheit. All right, so now we have some temperatures, so let's figure it out. So this is warm or warmer, and this is cooler. Well, warm, remember the W, makes this the low pressure system. And this is the high pressure system. Look at how the wind is blowing. It's going from high to low. So during the day at around noon, if this is me and I'm going to the beach, I will be fighting the wind because the wind is blowing this way. Okay? So fine. Now let's switch it to nighttime. All right, so now at nighttime, now it's cold, or it's the coldest time of the day. Either early morning or at night once the sun has gone down, you have the coolest times of the day. So remember, the sea doesn't really change its temperature that much because it has that high specific heat. It takes a long time to change temperature, so it's going to stay roughly the same. Land is going to change quite a bit. Land is going to cool all the way down, let's say, to 55 degrees Fahrenheit. They change their temperature super, super fast because they have that low specific heat, right? They're made of granite. So now, mark down where you're warmer and you're cooler. Warmer is your low pressure system. Oh, sorry. This is your high pressure system. And wind blows from high to low. So if this was me starting to head home for the day because it's nighttime, well, now I'm going back into the wind again. So I'd really need to time my bike rides properly in order to not have to deal with the wind at all. Okay? So here, I'm just reminding you, specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance, of any substance, 1 degree. So how much heat energy is needed to just raise the temperature 1 degree Celsius? And look, this is the sea, and this is the land. All right? You got this versus this. The higher the specific heat, the longer it takes. Okay, it's going to go very, very slowly. So remember, the sea's temperature stayed pretty much the same the entire time. It was the land that changed, all right? And that's because it has a low specific heat and it changes its temperatures very easily. Okay, this animation was a really good one, but it requires flash and I couldn't really make it happen. So sorry about that. All right, so here's your animation. It's just going to review exactly what we said. So notice daytime versus nighttime, okay? So take a look. In the daytime, land has a low specific heat, so it's going to warm up faster versus your water. So land is warmer, so it rises, low pressure. Water is your high pressure, cooler temperatures. Wind goes from high to low. So it's coming from the sea. So that's why it's called a sea breeze. Versus a land breeze, which is the opposite, right? Now it's the coldest time of day, and the land is going to be colder than the water. So it's going to be warmer at the water, so it goes up, low pressure. High pressure is going to be your cooler temperatures, which is over land, so it sinks. And there's your land breeze. It's going from high pressure to low pressure from the land. Okay? One other thing I wanted to go over with you guys is basically orographic lifting. It's also known as the mountain effect. Anytime you have the sea and then land, okay? It's basically a coastal area. You're going to have winds coming in from the sea. And if they're getting all that moisture from the sea, then that's going to be wet air. So if it's warm and wet, that's going to be your low pressure. Okay? And then since it's warm, it's going to rise. So as it rises, it cools, and that's going to lead to condensation and precipitation all the way up here. Okay? Now, after that, after it loses all that moisture, it's now going to be dry and cold. So it's going to start sinking, right? Dry and cold air is more dense, so it sinks. And now it's going to warm up at the bottom, and now it's warm and dry. So take a look at our two ecosystems now. You have cool and wet rainforest are on the left side of the mountain, on the side towards the water, and you have your warm and dry desert on the other side of the mountain. Okay, so that side where the wind is coming from, that's called the windward side. That's always going to be your low pressure system because that's the wet side. And then you have what's called the leeward side, which is your high pressure system, which is the dry side. Okay? All right, so here are your summary questions. So according to this diagram, as air rises on the windward side, The air's temperature decreases. Which process usually causes the temperature to decrease? All right, when you think of things getting colder, is it expanding or compressing? It should be compressing, okay? Next one, a cool breeze is blowing toward the land from the ocean of a warm, cloudless summer day. So here, blowing to the land from the ocean. So this is a sea breeze. The condition is most likely caused by the air temperature being higher over the land. All right, so listen, for these types of questions, my advice to you is to just draw a quick little diagram. If it's a breeze blowing to the land like this, then you know that this is high, this is low, that this is warm, that this is cool. And if you know that, then you're good. Then you know that this is a sea breeze because it's coming from the sea. All right, so as far as your job for tonight, the worksheet, I mean, this was where you could have kept your, took your notes. This was again, your note sheet, which would have been fine. These are those diagrams that you could have wrote in. I want you guys to try to fill out this. If you understand it, again, it's coming straight from the notes. Fill in the blanks. All right? Hope everyone is staying safe. Miss you guys a ton. Adios.